Hello, parents and any teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at some of the ways that we'll address addition with your third grader. Now, in the Intro to Addition video, I talked about the meaning of addition and then some key strategies that we want them to use. The meaning of addition is really linked to the action, and these are not my meanings for addition. They come from the research. A lot of it is what I learned from cognitively guided instruction, and that project that was done in the University of Wisconsin had me thinking a bit more about what is involved with addition than just lining up columns and computing down a column. So that whole idea of action in problems, combining things, joining things, putting things together, or we have part-part total relationships. Those are actions and actions that you hear in the word problems that your children will be doing. Now, when we see a story problem or a symbol, let's see if we can write, let's say I see this problem written. I would read this most of the time, 417 plus 158. And some of you may be thinking, well, I would too, of course. How else would you read it, right? Well, when you read those symbols, it's totally mathematically correct. Nothing wrong with them. The only challenge is that you don't see the word plus in many word problems. That would be easier if they would just put the word plus in there, right? You see words like combine and put together and join. And when your children are asked to write the equation that goes along with the story, or in this case, the expression that goes with the story, they really are challenged by that. And we use a lot of different techniques trying to help them. But the key thing is understanding the action of the operation. What happens? We combine things, we put them together, we join. So if you would, when you see a problem like this with your child, try using that language when you read it. Talk about 417 combined with 158, or joined with 158, or put together with 158. We keep reinforcing that language and connecting it to these symbols. It will be helpful to your child. Now you can see some materials here. I have base 10 materials, 2 versions. And this is the main one that we will use with your third grader. The base 10, we have 100. We have tens and ones. My paper version, hundreds, tens, and ones. The thing with the paper version is when I turn it over and I'm trying to help your child think about how to draw pictures of these, it's a little easier for some children to draw the picture seeing this version versus this version. In this version, you always see the lines, no matter how I turn it. And you see, when I have them drawing pictures, I don't want them drawing in all the lines at this point. So we have strategies, and the strategies, we start to build the understanding with the models that we use. Now, your child would have been used to a strategy called Bridge to 10 or Bridge to 10 in grade 1. It would have been extended Bridge to the decade or Bridge to 100 in grade 2. So we introduce the strategy in grade 1. We reinforce and extend it to 2-digit numbers in grade 2. And then we keep on going into 3-digit numbers in grade 3. And they can extend on up. In the Intro to Addition video, I showed you that this Bridge to 10 strategy is really the associative property. And we'll look at that a bit here. So we're using a property approach to computation. Another thing that you'll hear and you see is them using place value to add. And you might hear terms like partial sums, and I'll show you a bit about what that is. But key for that is understanding the size of the unit within each place value. Now, as your children move up, we also have a thousands cube. That's 10 of these put together, right? So we have certain models that help with that. So use place value, the associative property. We can do doubling, and through the doubling, we're also starting to build the foundation for distributive property. Now, in grade 3, your child will be looking at a multiplication. And one of the things we hope that they understand is 3 times 7 is 21, but we can think of 7 as 5 and 2. So we could also do that as 3 5s and 3 2s. Use the distributive property, 3 4s and 3 3s. It's building flexibility. So we start with the models through addition and the doubling to start to build that foundation. And then as your children get into multiplication, they just aren't combining numbers, they're combining same size groups, same size rows. So foundationally, we're starting with addition with that idea and then building from there. Okay. Now, the other one is a counting on, and that is really counting on 1, 2, or 3 with an anywhere start. So those are some of the models using these. We've got some of the strategies, and then we've got the language for the word problems. Now, one thing your child may do is they may be told the story and asked to draw the picture, or they may be given an answer and asked to tell a story, or given a picture and asked to tell a story. We're trying to come at things from a variety of ways. Now, let me clear these off for now, and let's just look at some potential problems. And one thing I do want to mention is as we get into these, you're going to see that I'll start drawing some pictures. And my pictures will use, instead of a square for the 1 and an oblong for the 10 and a square for the 100, I'll draw this for a 1, this for a 10, this for a 100. What we find happen is as your children get going and they get trying to finish things quickly, these all start to look the same. So this is just a quick way to draw them. You'll see me drawing this. If I'm drawing 1,000, I actually draw a hexagon. Here's the center point and connect every other vertex. So you might see me draw that as a variation for 1,000. There are many ways to draw the cube. That's one way also. So we're going to draw key pictures. We're going to represent using key models, but let's start with use place value. And I just will do a couple of sample problems to show you how we're using this. Now let's just start with a problem like 117 plus 122. Okay. When I was in school, we would have written this vertically. And knowing our facts, we would have just worked down the columns. We would have worked very hard to line these up. Our focus would have been on alignment and then adding up each column. We really didn't focus on place value at all. But I'm going to draw the related picture. Here's 117. Now, any teachers who are watching, do you notice how I'm not just randomly putting these? I'm organizing them in a particular way in a 10-frame organization. I've got the 122, and I'm going to combine like terms. See, once I use the right model, I see I'm combining hundreds with hundreds, tens with tens, and ones with ones. I have to combine like terms, like units. When I do that, right, I get the 200, the 30, and the 9. Now, you may see or hear something like partial sums, and that's just a use place value approach. It's that I'm recording the sums of the place value. I have 100 and 100 is 200, 10 and 20 is 30, 7 and 2 is 9. Now, do you notice how I work this one left to right? When I'm using place value, I'm not required to go right to left. okay? Because I'm writing each partial sum, each place value sum. Now, I could have gone right to left. That would have been fine. I could have started in the middle. The key is I have to make sure that I combine each of the places. The reason this becomes important is I don't have to align. See, once I understand it's about combining like size units, I should be able to write the 117 and the 122 anywhere on the page and still get the correct answer, because I know I'm combining hundreds with hundreds, tens with tens, ones with ones. When your child gets to 5th grade, they'll be combining tenths with tenths and hundredths with hundredths. We combine like size terms. Now, in this particular example, no regrouping is required. This problem works out very neatly, but what if I just change it a little bit? Instead of adding 122, I add 125. Now, let's stick with, we've got very clear, we add like terms. I can do that here. I could write it vertically, or I could have left it horizontally. But I combine hundreds with hundreds. Either way. I combine tens with tens. I combine ones with ones. So I have 12 ones, or another way of thinking of that is a 10 and 2 ones. Okay. So I can combine these. Your children will see many of these and just do it mentally. They won't have to write this down. They'll even think, oh, I've got 230, 30 and 12, 42, 242. And that is what we're trying to do. Is it's not that the math is new, it's that we're using algebraic approaches to computation, which end up letting your children use more mental arithmetic to solve, right? Versus purely paper and pencil dependent. So we're building that playfulness with numbers and building that imagery so that when they see that 117, they've gotten to a point where they know what that looks like. And by the way, I didn't have to put the 7 there. I could have spread them out, these two. There's not a way I have to organize it. I've got the 125. See, combine like size pieces. Now, continue on. Let's say I'm going to do a problem like 802 plus 166. See, these are all done mentally. I have the hundreds together, that's 900. Tens, I only have 6 of them. Ones, I've got 8, 968. Combining like units. Okay, if I write this out, 900 plus 60 plus 8. See, it's just focusing in on place value. Okay, so partial sums is a way to focus on the place value sums is what we're doing. Now, that's using place value approach. Another way that we are looking, or another strategy, is a bridge to 10 strategy. Now, I think I showed you in the intro video, let's see if I have this, the 10 frame. And this is how your child is introduced to it in 1st grade. They have a 10 frame. They have these filled in with certain blocks, right? So let's say I have 9 on the inside. It doesn't matter which block is empty. That could have been empty. This one could have been empty. It's still 9, 1 fewer. And then I have 8 on the outside. Notice I don't have to put them all right right next to each other. But what is 9 and 8 the same as? 10 and 7. Now you may think, why am I spending time with that? My child knows 9 and 8. They've known it since first grade. They know it's 17. Why are you spending any time with this in grades 1 and 2? Well, because what we're doing is we're thinking of that 8 as 1 and 7. So, sorry, that's an equals. I'm thinking of the 8 as 1 put together with 7, right? And it doesn't matter which one I take. I can take any of them. But I'm thinking of as 1 put together with 7. Instead of the 1 associating with the 7, I'm associating the 1 with the 9. See, it's not about replacing knowing facts with this. It's that this is the imagery of the associative property. If they know their facts, that's great. It's helpful. For some children, this helps them learn their facts because it gives them an image that they can picture to come up with what 9 and 8 is. But more importantly, we're wanting your child to spend time with this because it's the associative property. Now, in grade 1, they're introduced to this. They might have been moving materials around like I did. They're linking 9 and 8 to 10 and 7. If they know that, right, in grade 2, they start to look at some of these. If I know 9 and 8 is the same as 10 and 7, what's 19 and 8 the same as? See, 20 and 7, it's the associative property. What's 19 and 18 the same as? 20 and 17. Or I could think of this as 17 and 20. I could associate the other direction. What about 29 and 18? So in grade 2, we extend beyond just the fact level and building that associative property imagery at the fact level to extending it to 2-digit. And then you may see something like, I need to do something with 97. And let's say I'm combining 97 with, I'm going to do 35. Can you already see what we need to be doing here? Right? If I combine 97 with 35, I need to fill that hole in. How can I fill the hole in? Well, I can move those 3 up there and I fill that hole. What is 97 plus 35? Same as 100 plus 32. I'm bridging to the 100, but I'm using the associative property. So I can start to look at problems like this. 99 and 18, the same as 117, put together with 17. I'm bridging. I'm using the associative property. And if it works there, it will work for decimals. What's 99 hundredths and 18 hundredths put together with 18 hundredths? Same as a whole, 100 hundredths put together with 17. And I know it's lightly shaded, but right here, this one's unshaded. I've got this 27 there, sorry, 18 hundredths there. And what do? I fill one of these in. That's the imagery for what they're doing with an associative property. But then I can use that to solve things and make it much easier on myself where, again, the properties turn what would have been paper and pencil required to a mental strategy. Can you see how to do this one already? I don't always have to go to the left. See, what is 287 put together with 399 the same as? 686. Done. Mental arithmetic. Essentially what I did, I thought of that 287 as 286 put together with 1. Instead of associating the 1 with the 286, I'm going to associate the 1 with the 399. Okay, associative property. I don't have to record all of this. I can start to show them this in grade 3. And some of your children may be seeing this, but they're doing this. And we want to make that connection. And it's the imagery, the materials, or the model that helps us. Same idea. I could just use this for 87 put together with 298. Same idea, right? What is this the same as? 85 put together with 300. A mental strategy. Could I use place value to do this? Sure, I could. But it's much more efficient to do this. The key is we want your child thinking, oh, I could use place value. Oh, I could do a bridge to 10, use the associative property. Oh, I could do this. See, it's them being playful with number. Procedural fluency is about your child's ability to know multiple strategies and then pick one that they think is efficient. It's not to find a strategy to get the answer. It's really to use multiple strategies when they're computing. Now, another strategy we use is a doubling idea. Now, I just want to show you a problem like, let's do double 53. Now, in grade 2, this is how double 53 was written. In grade 3, your child in grade 4 will eventually be doing something like this. Double 53. Now you hear my language. I didn't read it as 2 times 53 or 53 plus 53. I'm still using that double language. So I've got double 53. Now think about what this looks like. Here's my 53. How did I represent double 53? Well, I have double 50 put together with double 3. The model helps me start to show the distributive property. That's the distributive property. Double 50 plus double 3. What do I have? I have 106. So that doubling strategy lets me get to the distributive property. As I said, when your children are starting to work on that multiplication, even something as simple as 3 times 7, see, we're wanting them to start to think about, well, you could think of that 7 as 5 and 2. It would look like this more. So if I have 3 7s, what do I have? I have 3 5s put together with 3 2s. Now I could have represented 7 as 4 and 3 or 1 and 6. And they want that flexibility for them. And it's that early distributive property. But how do we start with the distributive property? Back with problems where the place value comes out. And it's very clear with doubling how I can double 50, double the 3. So those two coming together are really important. So with the doubling, let's say I want to do 300 plus 300. Now in grade 1, they're working on early doubles and they might double 3. And they know double 3 is 6. And in grade 2, and even the end of year, grade 1, it's simple, relatively simple, to make the transition to say, well, if double 3 is 6, what's double 30 or double 3 10s? So if 3 and 3 is 6, 3 10s and 3 10s is 6 10s or 60. 300s and 300s is 600. So that is built up through this using place value models. Now, if I know double 300 is 600, see, I can use that understanding to do double 299. Now, when I was in elementary school, I've kind of alluded to the fact that I would have had to write this vertically. I would have done what we call carrying. right? 9 and 9 is 18, carry the 1. We talk about now more as regrouping, rethinking of that 18 ones as a 10 and 8 ones. But see, this paper and pencil becomes a mental problem because what is this? This is double 300 minus 2. I'm adjusting. So I've got 600 minus 2. Oh, that's 598. As they move into grade 4, see, how can I think of double 299? Well, what do we just do? Double 300 minus 2. Or how did we think of that 299? Well, we thought of it as 300 minus 1, distributive property. So again, we're using the imagery so that we can build the imagery for the properties, not just doing imagery for imagery, not to fill in from doing the algorithms we learned. But see, many of us learned arithmetic approaches to compute, and we're trying to develop the algebraic approaches to compute. Now, one last strategy you may see is a count-on strategy. I just want to think about a problem like this. See, this would have been a problem that when I was in school, as I said, it would have looked something like this. 8 and 3, we would have written that. We would have had to regroup twice to get to 201. Plus, we would have had to write it down. Just bringing out the paper and pencil would have taken time. But if I can count on with an anywhere start, 198 plus 3, well, we've got 199, 200, 201, done. Or I may think of, well, 2 gets me to 200, 1 more gets me to 201. I could break up the 3 into 1 and 2. That counting on 1, 2, or 3, 10, 20, 30, 100, 200, 300 can be more efficient. Now, typically, if it's more than 1, 2, or 3, or a multiple, right, 10, 20, 30, 100, 200, 300, we're going to have other more efficient strategies. But this works quite well to get me to the 201. And even more importantly, what if I want to remove 3 from 201? Think about regrouping across zeros and how hard that is. But counting back 3 is quite simple. So we're trying to use strategies with addition and models that will actually translate as they go up through the grades into the work that they will do with mixed numbers, with decimal numbers. They are algebraic properties, so they're actually seeing specific examples of the associative property and the distributive property if we purposely select our models. And that's why you're seeing your child working with certain models when you're thinking, oh, but they already know their facts. It's to build the imagery for the algebraic property side. So I hope this video was helpful. If so, please give it a thumbs up. Click on the notifications bell and subscribe to the channel so you'll know when other videos are available. If you have children in other grade levels, I hope you'll take a moment to watch those videos and look at how addition is developed in those grades. And thank you so much for watching.